Hello students, this is Professor Gina and I am going to do some sample problems for sections 7.2 and 7.3. In section, both of these sections have quite a few formulas, and normally you would be asked to memorize the formulas, but because everything is online now, I'm just going to let you know which formulas are the most important to use going forward. In your calculus classes, you'll probably be asked to have some of these on in your memory for exam. So I just want to kind of remind you of that. All right, for our first example, we are given the tangent of an angle, negative 15 over 8. And we know that the angle is in quadrant 2. And we're being asked to find the sine of twice the angle, the cosine of twice the angle, and the tangent of twice the angle. So what we'll do first is draw a picture to denote where this angle is and what it looks like. It's over here in quadrant 2. And remember that what I've drawn here is just the reference angle. Technically, the angle that we're considering is like this. And so we can't just take that negative 15 over 8 and double it, for example, to get the tangent of 2 theta, because 2 times theta is going to be twice this angle. It's going to be, somewhere around here maybe, right? We're not sure if it's in quadrant 3 or quadrant 4, but it's going to be a significantly larger angle. So let's use what we have. We know that the tangent of an angle is the opposite side over the adjacent side. So I'll take the 2 components that I have, that 15 and that 8, and I'll put the opposite side here. I'll put the 15 here, and then I'll put the 8 here. And then the positive negative relates to the fact that we're in the second quadrant. So the 8 is the one that's going to be negative. When we have a fraction that is negative, we have 3 ways of writing it. We can write it with the negative sign in front of it. We can have the negative sign in the numerator, or we can have the negative sign in the denominator. And in this case, we're choosing this third option where the 8 is the negative part. These are all mathematically the same, right? They're the same value, but we just choose which one makes more sense based on the quadrant that we're in for trig. And then what we'll do, we've got to find the length of our hypotenuse, so we'll use the Pythagorean theorem. So use Pythagorean theorem to find the hypotenuse. So let's see, I've got negative 8 squared plus 15 squared is equal to the hypotenuse squared. 64 plus 225 is equal to h squared. So I'm getting 289. And then if I take the square root of both sides, we're getting that the hypotenuse is 17 there. Okay. So then what we can do is we can use some of the formulas that were given to us in this section to find the sine of 2 times the angle. The formula that we have is 2 times the sine of the angle multiplied by the cosine of the angle. Well, the picture that I've drawn here gives me the values of sine and cosine. The sine of this angle is 15 over 17, and the cosine of this angle is negative 8 over 17. So we can multiply this whole thing together. And let's see, 2. I'm getting negative 240 over 289. So that's our first answer for the sine of 2 times theta. And then for the cosine of 2 theta, we can use the formula cosine squared theta minus sine squared theta. So let's see, the cosine we said was negative 8 over 17. We'll square that value. The sine is 15 over 17. We'll square that value. So we have 64 over 289 minus 225 over 289. And that gives us negative 161 over 289. That's the cosine of 2 theta. Okay. Once we have sine and cosine, we can use those two values to get the tangent. Tangent of 2 theta is just going to be the sine of 2 theta over the cosine of 2 theta, or negative 240 over 289. That's the sine value. And then negative 161 over 289. That's the cosine value. Just plug that into your calculator. Your calculator will do all the heavy lifting for you, and you should get 240 over 161. That's the tangent of 2 times theta. I don't know if I wrote it, but I know in a lot of these questions in my math lab, they also will ask you what is the quadrant of 2 times theta? What quadrant does it end up in? And the way that we do that is by finding two of the trig values. For example, when I look at the sign, positive or negative of sine and of cosine, we have that the sine of 2 theta is negative. And the cosine of 2 theta is also negative. And that happens when an angle is in quadrant 3. So that's what we think. The original angle that we had, which was theta, was in quadrant 2. So that means that it's between 90 degrees and 180 degrees. So if I were to multiply all three of these items by 2, I have 2 times theta is between 360 degrees and 180 degrees. So this could be in either in quadrant 3 or in quadrant 4. And so we have to do a little bit of extra investigating before we make a final decision about which quadrant it is in. All right, next problem. All right, let's, this is kind of a similar problem. We're given that the sine of an angle is negative square root 10 over 10. And that angle is in quadrant 4. And we're going to do the same thing that we did in the last one. We're going to find the sine of 2 times theta, the cosine of 2 times theta, the tangent of 2 theta, and the quadrant of 2 times theta. Okay. So like the last problem, we started by drawing a picture. And we have something like this. The sine of an angle is the opposite side over the hypotenuse. So looking at the fraction, we've got a square root 10 in the numerator, so that square root 10 is going to go here, and the 10 is going to go here for the hypotenuse. The hypotenuse is never negative, so we'll put the negative sign in front of the square root 10. And then we'll use the Pythagorean theorem to find the x component. So we'll have x squared plus negative square root of 10 squared equals 10 squared. X, when I square a negative sign, negative times negative changes to positive, and I'm also squaring a square root, so that's going to end up being 10. Subtract 10 from both sides, and we get that x squared is equal to 90, or x is the square root of 90. We would probably write that instead as 3 times the square root of 10. So that's going to be this side here, 3 root 10. Okay, then we'll go to our formulas. The sine of 2 times theta is 2 sine theta cosine theta. The sine was given to us negative root 10 over 10, and the cosine is 3 root 10 over 10. Multiplying that all together, we're going to get, let's see, negative 60, I think, over 100. Yeah, and that simplifies to negative 3/5. So that's our answer for the first part. For the cosine of 2 times theta, we'll use cosine squared theta minus sine squared theta. So we'll take those same values we had before there. We'll do 3 root 10 over 10 squared minus negative root 10 over 10, the quantity squared. So when I square this first fraction, I'm going to get 9 times 10, which is 90 over 100. And then here I'm going to get 10 over 100. So it looks like I'm getting 80 over 100, or 4/5. So that's our answer for the second part. And to find tangent, we'll use the sine and the cosine values. The tangent of 2 theta will be sine of 2 theta over cosine of 2 theta, or negative 3/5 divided by 4/5. And that will be negative 3/4. And then for the final part, we want to know what quadrant this is in. So we know that the sine of 2 theta is negative. The cosine of 2 theta is positive. And that happens when an angle is in quadrant 4. So 2 times theta is in quadrant 4. Well, how could that be possible? Let's think about that. So the original angle that they gave us was in quadrant 4, which is between 270 degrees and 360 degrees. So if I double all of these values, this is 540 degrees. and this is 720 degrees. So we've gone around the circle more than once, and that's how we're ending up back again in quadrant 4. Okay, the next set of problems are using the half angle identity. Some of the, and this, I'm just showing you some of the processes for these, but most of these problems, when you move on in calculus, a lot of them can be handled in your calculator. Some of them, the calculator will give you the exact value. Some of them, it'll give you a decimal answer. Most of the time, your professors will want an exact answer. So if your calculator isn't working, these are the formulas that you would need to use. Let's find the tangent of 67.5 degrees. If we are trying to find the trig value of something that's not on the unit circle, we use unit circle values that we have to find those other angle values. So if we double 67.5, we get 135, and that's one of our angles on the unit circle. So instead of writing this as 67.5, I'm going to write it instead as, 135 divided by 2. That's a different way of writing 67.5. The formula that we have is that the tangent of some angle that's being split in half is 1 minus the cosine of the original angle, and then divided by the sine of the angle. So in this case, x is 135. That's the part that we're going to be considering as x. So we'll write this as 1 minus the cosine of 135 degrees over the sine of 135 degrees. Well, the cosine and the sine of 135 degrees are over, those are, the reference angle is 45 degrees, and it's in the second quadrant. So the cosine is negative root 2 over 2. And then the sine is positive square root of 2 over 2. To simplify this, I've got complex fractions. What I'm going to do is I'm going to multiply the whole thing by 2 over 2, so I can clear those denominators. Remember that this 2 is going to distribute to the 1 here and then also to the fraction here, right? So we have 2 minus and minus will change to plus the square root of 2, and in the denominator we have square root of 2. Technically, we don't want to leave a radical in the denominator, so we'll multiply by square root of 2 over square root of 2 to rationalize. And then I'll have 2 root 2 plus 2 over 2. And we can simplify that to be the square root of 2 plus 1. When we split up a fraction like that, we have to split it into 2 separate components so that the 2 in the denominator divides into both items. So this is the tangent of 67.5 degrees. All right. Let me see if that one, if the calculator does that one. Tangent 67.5. No, on the calculator, it'll just give you a decimal answer. So this is the exact answer. Let's do another one like this. Let's find the cosine of pi over 8. Pi over 8 is the same as pi over 4 cut in half, right? Oops, I don't want to write it that way. So pi over 4 divided by 2, right? The formula that we have for the half angle of cosine is the cosine of some angle split in half is plus or minus the square root of 1 plus cosine of the angle divided by 2. The plus or minus comes from us understanding what quadrant that angle is in. And pi over 8 is in quadrant 1. Pi over 8 is in quadrant 1. So we know that the value is going to be positive for the cosine. So let's use that formula. I'm going to have positive 1 plus the cosine of pi over 4 divided by 2, and then take the square root of the whole thing. So I guess I don't need the plus there. 1 plus square root of 2 over 2 divided by 2. I'm going to multiply everything on the inside of this radical by 2 over 2. Because I've got that fraction in the numerator. The 2 is going to distribute to both items up on top. So it'll distribute to the 1 and then also to the fraction. That'll give me 2 plus the square root of 2, and then in the denominator we have 4. This is going to look a little funny, but the way that we write our answer often is 2 plus the square root of 2, and we keep a square root of that whole thing, and then we have 2 in the denominator. What we did was we split this up into the numerator separated by the denominator. We end up with no radical in the denominator, so that's fine. There are a number of techniques where you can change this so that you don't have what's called a nested radical, these square root of 2 underneath a larger radical, but that's not terribly important for you to worry about. Okay, let's switch gears and do a couple. I'm going to do one that's slightly different. It's got a calculator value. Hang on 1 second. Okay. In this example, we are given that the sine of an angle is approximately 0.3416. And we want to find the sine of 2 times the angle. We know that the formula is sine of 2 times an angle is 2 sine theta times cosine theta. We were given the sine, and we can use the Pythagorean theorem to find the cosine. Sine squared theta plus cosine squared theta equals 1. Rearranging that, we have cosine squared theta equals 1 minus the sine squared theta. And then taking the square root of both sides, we have 1 minus sine squared theta, but then with a square root around it, right? Plus or minus. In this particular case, we're just going to assume that we are in the first quadrant. So we'll just take the positive value. So let's plug in one minus 0.3416 squared. and then take the square root. And we're getting that that's approximately 3,416. I'm getting 0.9398. So now I've got two values that I can plug in back to my original. 2 times 0.3416 and multiplied by 0.9398. And so for sine of 2 theta, I'm going to get about 0.6421. Okay, and then I have just two more examples that are kind of just review from some of the things that we need to do as far as factoring. And I did some problems like this last week, so I just wanted to do a couple review. Let's simplify, but they're using some of the new formulas that we have. Let's simplify cosine to the 4th power of x minus sine to the 4th power of x. This is in the format of, let's just say, a to the 4th power minus b to the 4th power, which is a difference of squares. We could split this up into a squared plus b squared and a squared minus b squared. We've got to get comfortable recognizing something when it's in a format of something we know. So in this case, a is the cosine of x and b is the sine of x, right? So splitting this up, I have cosine squared x plus sine squared x. And then I have cosine squared x minus sine squared x. Well, this is another difference of squares again. So we can repeat that process again. And this becomes cosine of x plus sine of x and cosine of x minus sine of x. Oh, wait a minute. Rather than doing that, pause. We can, I'm just looking at my notes, realizing that I did something different. First of all, this is a Pythagorean identity, right? This is a Pythagorean identity. This is just equal to 1. And then this is a double angle. We could factor it, but we could also recognize that it's a double angle, which is cosine of 2 times x. So I think in this case, we can just put cosine of 2x as our answer. That looks better than what I was going to end up with. Okay, one more problem. Let's simplify. This one's going to look really yucky to start. 1 plus sine of 2x plus cosine of 2x over 1 plus sine of 2x minus cosine of 2x. Oftentimes in calculus, you'll get a complicated trig function and you want to simplify it so that you can take an integral or you can take a derivative. And this would be an example of something we could minimize the complexity of it. So what I'm going to do is use the double angle formulas to exchange each of these. For the first part, I'll leave the ones as they are. But I'm going to make an exchange for sine of 2x. Instead, I'll use the double angle and I'll call it 2 sine of x cosine of x. Do that for both both the top and the bottom. 2 sine of x cosine of x. Right, so I've just dealt with this part here and this part here. And then continuing for the I wanted to get rid of that. The next part, I'll use double angle formula again. This will be plus. I want some things to cancel, and so I've kind of worked ahead and looked at some things that would work out better. We know we have a lot of options for cosine of 2 times an angle. For the one in the numerator, I'm going to use 2 cosine squared x minus 1. That's one of our options. But I'm going to use something different for the denominator. I'm going to use 1 minus 2 sine squared x for the denominator. These are 2 different versions. We were using a different version before earlier. There are 3 different versions for cosine. All right, so let's see what happens here. Well, in the numerator, to start, I've got a 1 here and a -1 here. So those are going to cancel, right? Those are going to go away. So let's see what I've got left. I've got 2 sine of x cosine of x plus 2 cosine squared x. Okay. And then similarly in the denominator, this 1 and this -1 are going to change. So in the denominator, I'll have 2 sine of x cosine of x. But remember that this negative is going to distribute here, and that's going to change to positive. So plus 2 sine squared of x. Now I'm going to factor. So let's factor, and we'll take out a cosine x on the top. 2 cosine x will come out on the top. And I'm left with sine x plus cosine x. And the bottom, I'll factor out a 2 sine of x. And I'm left with, oops, I'm missing an x there. Cosine of x plus sine of x. Well, that's kind of cool because then these 2 things are going to cancel each other right here. And the 2's are also going to cancel. So I'm just left with cosine x over sine of x. That's kind of crazy. That's going to end up just being cotangent of x. That whole crazy mess up there in the top ended up simplifying just to cotangent. All right, I'm going to pause here and then start some section 7.3 in just a second. All right, I am back to do a few examples for section 7.3. I'm only focusing on the sum to product and product to sum in this section. For this example, you're not going to be doing any proofs. We've just got to cut a couple of things out, and it's not necessary for you to do the proofs in this section. For section 7.3, only sum to product, which you use these a lot in calculus, and product to sum. Formulas. So I'm going to do 3 examples of these. Okay, so for our first example, let's look at sine of 7x minus the sine of 4x. And what we want to do is change that into its different format. The sum to product formula means that we're taking a sum, 2 things that are added together. Here we've got sines of 2 different angles. In this case, they're subtracted, but that's still a sum, adding a negative number. And we're changing it to 2 items that are multiplied. Again, these are things that'll be useful for you in calculus when you're trying to integrate. because you can break things apart when they're multiplied as opposed to being added or subtracted. So one of the formulas that you have is if you have the sine of an angle minus the sine of a different angle, you can split that up into two cosine. You take the two angles and you add them together over 2, and then sine of the angle subtracted over 2. That should be a y. All right, so we'll have 2 times the cosine of 7x plus 4x over 2. I'm taking the two angles, 7x is one and 4x is the other. And then multiplied by the sine of 7x minus 4x over 2. So that ends up being 2 cosine 11x over 2 times the sine of 3x over 2. And that's your answer. Not too bad. For our second example, we're going to go in the opposite direction. We're going to be starting with a product, 2 times the sine of 7 theta times the cosine of 3 theta. Here we're going to use the product to sum formula. So there are different versions. In this case, I have sine of an angle multiplied by cosine of an angle. And that'll split up into 1/2 times the quantity, sine of x plus y, plus sine of x minus y. Oops, that got all weird. X minus y. I'm too close to the edge. Okay. So we'll do 2 times, oops. We're going to do 1/2 sine of 7 theta plus 3 theta, and then sine of 7 theta minus 3 theta. So 1/2 sine of 10 theta times sine of 4 theta. And that's our answer. Oh, wait a minute. Boo, I started right and then I forgot this. There was a 2 in front, right? Forgot about that guy. Because the formula that we have is just this part here. So I have this 2 that's out in front that I didn't take into account. So I think my final answer should be sine of 10 theta times sine of 4 theta. Yeah, that looks better. Okay, one more. And clearly I'm getting tired because I'm starting to make mistakes. For this last example, I have 7 cosine of 5 times theta times the cosine of 7 theta. This is a different product to sum, because this one involves cosines. So when I have cosine of x times cosine of y, we can change that into 1/2 cosine x minus y. These are backwards from the other one, and then plus cosine x plus y. This one has the x minus y first, whereas when we were up here with cosine, it had the x minus y second. Sine and cosine are slightly different. All right, so I'm going to remember this time that I've got a 7 there in front. So I'm going to go 7 And then I've got a 1/2 cosine 5 theta minus 7 theta plus cosine 5 theta plus 7 theta. A little too close there, right? So 7/2 cosine -2 times theta and cosine of 12 times theta. Cosine is an even function. So that means when you take cosine of a negative angle, it's the same as just cosine of the positive angle. So we can get rid of that negative sign that's in the inside there. So we'll have 7/2 cosine 2 theta times cosine 12 theta. All right. Thank you for watching. And if you have questions, as always, send me an email. Have a great day.